second lecture, or actually the first lecture for this week. Today we'll be discussing a bit about the levels of testing. We do have a bit more theory to cover today, but we will try to be as engaging as we could be. So we will have a little interesting lab exercise moving along the way, and we'll start off with a little, let's say, experience sharing. So I will now share my screen. And check this is the one. All right. Are you able to see my screen? Okay, perfect. All right. So before we start today's lecture, I want us to do this little activity that is written down here. So basically, we take this scenario. The testing team at a prominent e-commerce company undertook a significant revamp of its online shopping platform to elevate user experience, boost performance, and unveil new features. Now, tasked with ensuring that the platform will be reliable, functional, and secure, the testing team decided to decompose each testing aspect into smaller tests. So essentially, breaking down the larger, let's say, task into smaller ones to have better coverage. Now, what I would like all of you to do is in the live chat in Slack, share any instances from your life where you've encountered a similar situation to this testing team. So this doesn't have to be connected to testing or anything. It's just a problem that required a solution of essentially breaking down some steps in order to reach the final phase. In addition to that, think about the first question: how did breaking down the problem into smaller tasks help you manage it more effectively? I can start with an example right off the bat. Since I am a person who really loves to plan his travels, we had an issue of having to organize a lot of people to have a 16-day trip to Japan. And the way that I approached it after having millions of options to, let's say, discover, I would simply take what were my top 5 places to visit. And then after that, I cut down what are my top 5 places to visit in that current city that I want to go to first. And then after doing that, I kind of narrowed everything down to more simplified, let's say, ideas which are realistic to achieve and manage to, let's say, get a satisfactory solution. So let's see what you have to mention in the live chat. So monthly income costs, okay. You can also share how did breaking down the problem into smaller tasks help you manage it more effectively. So um, did it help you maybe, let's say, understand what is the best approach, or did it help you find, okay, and to avoid visits? Okay, yeah, understandable, right? Wonderful. So I see some people are typing in the chat while that's going. Valentin, that's a interesting, it's a very actually simple example as well, which are most economic, but still giving good service, electricity companies. Wonderful. Wonderful. So you kind of got a track of how to, let's say, manage the costs just by structuring them into steps that you would do. Products data storage. Okay. Also an interesting example. Okay. Let's see another information here. There is a lifestyle. I'll try to break down everything to simplify and not complicate a problem that may seem huge, but it's not. Okay. At Amazon, we have areas like AFCs, sort centers, and delivery station, which works together to help the company get customers' orders to their doorsteps. Wonderful. So we see we have a sort of solution that is made up of multiple stations that kind of come together and then give the final product. Project management and construction. You cannot start with the roof before the foundation. That's a wonderful example, Susan. So great. Quite straightforward. All right. Wonderful. Yeah. So I assume as we see some of these examples, and you're feel free to leave more in the chat. When you do have a, let's say, larger problem or task, it's often the best way to go about it to kind of divide it into smaller chunks and then try to solve each of those chunks, after which you would combine all of them and get the final solution. So this way you will also be able to have more focus towards the specific tasks. And in addition to that, you would cut down on the time and effort that you would need when you finalize everything, since everything will be specifically solved. Maybe there will be some small things that could be fixed here and there, which is normal, but still the amount of work that you would need to put in to bring the solution of the task to the utmost quality will definitely be at the highest level. So that is exactly what we will be talking in today's lecture. So let me just move the zoom here, which is levels of testing. So similar to the scenarios that all of you mentioned here in the chat, I would like to say that it is the same with testing. So you could take and, let's say, test an application from start to finish without even taking into consideration what aspects that you will need to cover or at which stage of testing you are. And most likely you will find plenty of issues. However, the issue that is the most common in this scenario is that you will be uncertain which scenarios you might have left off, or which critical components might not have been tested, which system interfaces might have been missed. So you have a lot of these parameters that will definitely go unnoticed or not unchecked when trying to test everything in a single chunk. So that's why we have these different levels of testing. Now, we also see here an practical example where there is a new software update is released, and then we have errors, crashes, vulnerabilities. So the way that you can tackle this is actually implementing the levels of testing. And the idea of today's lecture will be just that. So we will see what are the levels of testing, how we can implement them, what are the steps taken during each separate step of those levels of testing, and how do they provide quality, reliability, and good functionality from each aspect, both functional, non-functional. We'll also see what is the scope and significance of each test level from component to acceptance testing, and you will also notice that you're actually familiar with these levels of testing. Maybe not in this terminology, but you have seen them in some of the previous lectures. So that is basically the intro, and the main objectives would be to gain knowledge to analyze hierarchical structure of software testing levels, explain the concept and significance of each level, describe the independence among different testing levels, highlight how each level contributes to the overall testing process. So each level has its own contribution in its own weight. So depending on the type of testing, importance, speed, cost, so on and so forth. And of course, in addition to the levels of testing, we will see some challenges and effective strategies associated with maintenance testing, which is one of the most, I would say, common types of testing on most projects. Okay, I will move into the first part of the lecture, and that is what are the levels of software testing. Now, here we have a very wonderful graphic, which I will return to when we go first through the material section. And I would like to have your assistance in parts while going through at least this bit of the lecture. So test levels are essentially, let's call it a structure, as it's stated here, that show where we have gaps within an application, prevent overlap, and reduce redundancy in the software development lifecycle. So the idea of the software testing levels are that you do not actually start to test when you reach the final phase of the project. For example, everything has been developed and now you can test it. But the idea here is that testing is actually present throughout all the different phases of this life cycle. So when a component is finished, you want to make sure that tests are run for that component. When you connect it to another, you want to check the connection. When you build a certain system, you want to ensure that all those connections and components all together worked as a whole. You want to also make sure that requirements are met. So in order to not have to do all of this at the same time after everything is developed, this system known as test levels has been, let's say, introduced. Now, when talking about levels of software testing, there are a few, and as I mentioned, you are familiar with some of them. So I'm going to scroll a bit down now to the first one, which is component testing. Now, I believe we already saw this in another name in the previous lecture, which is unit testing. And as we discussed previously, this is a type of testing that focuses on testing separate components in isolation. So you're only testing the component. You're not interested in how it interacts with the remaining 6 components, 10 components. You're just testing that specific component, whether it's performing its necessary functionalities and actions. So in regards to this type of testing, since we already mentioned it, can anybody write an example that they have in the chat? It could be anything, so we're not limiting it here to actual software. You can also use real life examples. It's just same bit of it. So let's see. I see Francesco is typing right now, so feel free. There are no wrong answers, so and you don't have to go into too much detail. So just specifying just a simple example on what is tested. So no need for too much details. It's just for an example. Right, I see multiple people typing in the chat. Let's see. And then I'll move on to see the example that we have provided here. Okay. In language teaching, teaching students a specific type of grammar, definition, use cases, construction. Exactly. Yep. That's actually a very good real life example. Very nice, Susan. And yeah, specific type of grammar. So we're not really focused on, let's say, how present tense and past tense works together. We're just interested in that one segment and what are the rules for that one. Testing WhatsApp call history. Yep, excellent. Yep. This could also be a bit generalized because it maybe has other aspects, not only just looking who called when, but probably it's tied to other functionalities like trying to fetch the history. But I mean, it's still a good example because it's just one specific part of the entire application. It could be handled, let's say in this case, as a component. Yeah, wonderful. Daniel, you mentioned verify the component function as expected. That is correct. Alrighty. Yes, so we already have some examples and I can just move simply down. We have testing shipping cost function in a web app to ensure it calculates accurately. So we have a, let's say, price that is displayed, sending a message using a messaging app. Wonderful. That's also a very good example. And we can move here into an infinite amount of these since most apps are based on the foundation of having some components. So you can add here checking the, like it's written here, the cost function in a web application. You can also go ahead and say filters for an e-commerce site. So just the filters not connected to the search results view or the search term that's inputted. So strictly the filters. So that is the idea behind this. Now the next one, which I believe we also talked about in the previous lecture, is integration testing. Now, integration testing, as you might remember previously, tests how the connection between the components works. So how are they integrated? So let's say, let's take the example, money exchange rate calculation testing. So we have the example here provided by Bibi. So we have a conversion module. Now, aside from the conversion, we would also want to be able to convert and then maybe, let's say, pull the money from that specific currency. So we have dollars, we enter them, and we want to, let's say, take Macedonian dinars. They are converted. So this is one bit of the application, one component, and then they're sent over to let's say our account. So this is an imaginary scenario, and then we kind of get to test the interaction between converting and then transferring the funds. Can somebody else provide any other examples you might think of regarding integration testing? So regarding the communication between two components. Again, it can be some real life examples. You can write them in the chat, of course. I see multiple of you already writing in the chat. Let's see what are some examples. E-commerce web and payment gateways. Wonderful. Yep. Simple. Simple and straightforward. So obviously when you would go to an e-commerce website and then you try to select some items and then go to the payment, you are actually testing both the search result view item, then going to the cart and then trying to see whether everything is set there based on the information of the item. So you're actually testing some kind of interface between all of them. That's a wonderful. In a bookstore website, ensure cart totals are passed correctly to the payment API. Wonderful. That's a super example. Testing the functions of a mouse, keyboard, monitor connected to this. Wonderful. That's a very, that's a very good, actually example. I love that. It's a very straightforward and that's actually interfacing. So it is in a way checking whether all of them work combined on the computer. That's a very nice, real world example. Wonderful. All of the examples are great, so keep them going. We have one more type of testing for which I will ask for an example, and then the last one I think we can do without. We have system testing. So in contrast to these two, system testing checks the functionality of the entire system. So everything that is connected, all the components, how do they work together as a whole? So think of it in a way, here you perform full end-to-end tests. So you need to check an entire flow. So it's not just a connection between components, rather everything in the entire system. Now, do you have any ideas of examples that we can mention here? Yeah, it could. Think of the system as the entire application. So the system testing is focused on checking all the functionality. So does it include operating system? Yes, you could actually test an operating system, and probably this is done. I don't have so much experience regarding the operating systems, but I'm sure that it also goes. This like displays. Exactly, yes, like that, Valentina. So functionality from start to end. So you're not only focused now on the strict functionalities related to components and their interactions, but everything included within the application. So maybe browser, yeah, you could test a browser. And Hamut, regarding like displays, it's more like connected to entire applications. So it could, I would give you one more example. Verify the cart sends data to payment processor displays, adding product to the cart on the website, do the check and confirm order. Yeah, wonderful. So we have two great examples here, after the other. So I will use those. I will go here with Seraphim. So adding a product to the cart on the website, do the checkout and confirm the order. So here we can see we are testing something from start to finish. So you add the product to the cart, then you go to the checkout, and then you make sure that the order arrives. So whether this is, you go to the database to see if the payment got through, or use a mail, a dummy mail that is sent to you with the confirmation of the payment. So you're testing essentially everything within the system. It's not only limited to the components. So that is the idea behind it. Under system testing, you can also go and basically say, like you explained earlier, operating system, browser, those do fall under the category. The idea is you test an entire flow. Finally, we have acceptance testing. Now, acceptance testing, I don't think we have mentioned this that much previously. The idea for acceptance testing is as the name suggests. So that's a wonderful way to put it, confirming that stakeholders will pay you. It is a type of testing that ensures that the requirements from both the stakeholder side and the users are met. So basically, you need to get, let's say in a way, you should get your system should be accepted, hence the name acceptance testing. So they see if what they had as requirement, the stakeholders and the users, is what they see on the web page. That's why the name is acceptance testing. And it's quite common, actually. It's present on all products that are worked across the board. So you would definitely be coming across this type of testing more often than you would expect. So that is the idea behind it. Now, one thing I would also add to this section is the testing sequence. It's very important to have a sequence related to how you execute these types of tests and these levels of testing. And why is it important? Because when you have some kind of sequence, and we will talk about the specific sequence regarding the levels later on as well, you will actually have a very good way to structure the coverage. So if you start with the components, you will make sure that all of them work separately. Then when you check the interfaces in between them, you're reassuring yourself that, okay, the components are working, the communication between them is on point, so I'm good to go for now. Then you want to check the system to make sure all of them work as expected from your side. And then finally, after you ensure, okay, my application is wonderful, it's good to go, you simply just give it to the stakeholders and you devise a plan on how to go through the user scenarios and the requirements, either together or with external users. So this we'll touch a bit later on in this lecture. For now, does anyone have any questions regarding this? All right, no questions. Wonderful. Then I will move to the first level of testing, which is component testing or unit testing. Now, we talked briefly about unit testing previously, so the definition is already clear. It's just testing components in isolation. The thing that we should note here is that it is actually divided into white box and black box testing. I think you already went through both of these. We even had some experience on the Kahoot to see what were the things that were taken from previous lessons. And the idea is that the developers do the white box testing because it's more related to the code structure. So this is usually automated test scenarios that are done to make sure that the component works. And then black box testing is done by the QA, and it is often done manually. Now, as the other testing levels, we will also see, this type of testing has some core activities. You will notice that most of them are similar. So there is, let's call it a sort of flow that goes into covering the test levels. However, they do differ at some points, which you will see. So first, regarding the component testing is isolation of components. So it's important to make sure that the components are tested separately. So the components are not tested together with the others. We're just doing one at a time. So we have an example here, calculate total price. We mock dependency of the database sizes to focus solely on the logic of the method. So it's only related to this method. We're not trying to say calculate total price and then display the amount of the total in dollars. We're just doing this one method, and we write all of the tests or perform all of the tests regarding this specific method. Then defining test cases. Now, developers can create and most often do create test cases for scenarios regarding the components themselves. However, I would add here that there are specific types of, I would call them reviews or ceremonies within a development lifecycle, where the tester, the proxy product owner, and the developer meet, or it could be multiple people, of course, but this is essentially the idea, and it's called Three Amigos. Now, what you do on that meeting is you present test cases in a way that you base the test cases on the requirement and personal experience. So you try to note down what functionalities you think could be considered as having edge cases. For example, you have already worked on let's say a pagination previously, so you know that oftentimes when you click on the arrow to the right and you're at the final page, you could actually crash the search results. So having these test cases that you have prepared for your testing presented to the developer could also help in them defining the test cases that they do for the unit or component testing. So it's a very good thing to note and to keep in mind when working on projects, because it does really help both development, the testing team, and the quality of the project. So that's one thing I would add. Moving on, we have execution of tests. So component tests are executed automatically, as I mentioned previously. So this uses frameworks like JUnit, NUnit, PyTest. We already mentioned these previously. So this is executed and there are assertions that are made, which is the next point, to ensure that the actual and expected outputs match. So while they're being executed, assertions and validations are performed, and they make sure that whatever was added as an expected output is working as expected or is the actual output. Moving down, we have feedback and reporting. So after the tests are run, developers receive feedback on which test passed or failed. This is usually detailed information, and you will notice when even working with frameworks like Selenium later on, you would also get a very detailed report on what failed, where it failed, and then a description of that issue highlighted in red, which is nice. And when they would notice these issues, they should be able to immediately go to the point of the code that needs to be changed in regards to the component. Integration with CI pipelines. So as the code itself is integrated in pipelines, the test should also be done, should be implemented in the same pipeline, because it does, when you create a component, it doesn't mean that you have to run the test only once and that's it. You might sometimes come across a change to that component, and imagine just having to rewrite the tests one more time from zero. What's a common practice is you have them on the pipeline. When you do a modification to the component, you also do the modification to the tests. You run them automatically, moving on, and you get the results. So this is a very big part and important part of the unit testing process. And finally, we have refactoring and maintenance, which kind of is connected with the integration with CI pipelines, because it's important to refactor and to maintain this test. As I mentioned, you have components that are constantly changing, and having the tests being up to date, following all the changes, will ensure that whatever is modified is working still as expected, no underlying issues happen, or even if there are any issues, catch them and showcase where they need to be resolved. Now, when it comes to component testing, there are some best practices, as stated here, that should be followed, because it is quite easy to lose sight when working with too many components and going and designing various tests on what is the purpose of all of them. And I even go from my personal experience with that. So very important, test one thing at a time. So the idea is you need to focus on one specific aspect on the component you're working. So let's say the calculation of the prices. So if you're currently testing that method, you should only be interested in testing that, whether it works in a specific currency. Do not try to implement a method where you would just test the type of currency, how is displayed, what are the colors, what is the weight. It's better to have them separately so that you know that each step is tested thoroughly. Use descriptive test names. So this goes without saying, this is related to even basic development code practices. So the need for descriptive test names is so that both you, when you work with these tests, know what the test covers, because on bigger applications, it is a scenario where you would have a lot of tests that would need to be run. So having the idea of what test was this for is important. And also when you might not already be on this project and somebody else comes in to do the job that you were doing previously, they would also need to have an easier time of understanding of why this test was built and what is the purpose of it. So having descriptive test names is key. Keep tests independent. As I mentioned, do not overlap tests between each other. All components should be tested isolated on their own. Test edge cases. So in this type of testing, it's good to cover boundary conditions. As I mentioned, this is often realized through having this joint meeting with testers and developers where they would be able to see some specific scenarios that maybe the developers won't catch or the testers might not get an idea of due to the nature of the application maybe being unfamiliar. So covering them in component test is always a benefit. Aiming for high code coverage. So as much as the coverage can be, the better. So especially for the critical parts of the code. Test for failures too. Something that you might notice when working on project is that when you would try some negative scenarios, often you would find plenty of bugs, at least from my experience. So this is something that I have seen at least the developers in my team avoid from time to time. They would cover some failures, but the idea is you would try to see as much as the negative scenarios as possible. So testing for failures too is essential, and it also adds on to the high code coverage. So it's not only that positive scenarios work, but rather, do I get an error message when there are no results? This type of things should also be covered. Refactor tests regularly, so keeping the code clean and maintainable is important. Again, you need to understand and to get an idea of what was worked on when tracing back to the code, and newcomers should have an easy time to understand it. Run tests frequently, so automate and run tests with each code change to catch issues early. Again, so if there is a change, we need to run the test, we need to update them, we need to maintain them. So it's key to have them run regularly, especially when the changes occur, and writing minimalistic assertions. So the idea of the last one is you will see when we will be working with we'll be working more with Selenium and even with SNG. The assertions, it's okay to have a bit more assertions, but they do take up a lot of resources and memory code-wise. So when working with assertions is quite the best practice to just have as little as possible, but still cover the important aspects of the test. So do not overspecify behavior and make sure that the tests are maintainable. Okay, I think this is this for this section. Does anybody have any questions? Can you make an example of a minimalistic assertion in real life scenario? Okay, yeah, we can do this. Let's see. Okay, so let's say I am working in a bookstore, and we have a special section where we take in books that have been donated. So let's say that. And in that section, we have books that we want to, let's say, uh, give out for free, and then maybe some that would be resold for a small value. And that is dependent on the condition of the book. Now, when I take this book as the, let's say, the bookshop worker, I get to see the book. Now, what is important for me? For me, it is important what is the condition of the book. So I can assert if the book is in a terrible condition, I would simply just put it up for free. So it's maybe the pages are teared up. So I would just simply check whether and assert whether the book is in a terrible state, let's say by the pages being ripped off. I can just put that assertion, and there's no need for me to go into detail on, okay, there might be too many coffee stains. Okay, the book has, I don't know, probably had only one page removed, or that it is in a language that maybe is not similar to the native. Whereas for the ones that could go for sale, I would just also assert everything. So the book looks in good condition, so I can just put it up for a smaller price. Maybe not the best example, but you see, when I open up the old book, I don't really need to go into too much details and assert everything regarding, let's say, the stains on the pages, the ripped off covers, the wording of the language used inside the book. But I'm just making sure, okay, this book looks as it should. So I'm going to assert that the book has everything intact from pages, and then I can just put it in that area. So you're just kind of trying to think which aspects are more, let's say, important in the context that you're trying to write an assertion for. You don't really need to check every bit of what you're trying to test. Does it make sense? Exactly. Yeah. So again, you can write assertions for everything, but try to keep in mind what is the actual idea of what you're testing. So what is your goal? So um, just follow. Usually it will be given in the requirements when you work in these scenarios, but again, it's important to kind of avoid unnecessary assertions. Assertion is, I wouldn't say it's more random. You will have guidelines for what you really need to check, what is the most important aspect of something. So it's not random. Assertion is, it is structured, but the structure is designed by you. So you are the one who decides what is important so that you would say, okay, this works as expected. Because if I'm testing, let's say, a search functionality, I'm not really, let's say in isolation, I'm not really concerned when I input the terms, how they will be displayed later on. For the time being, I'm just interested in if they are displayed properly in the search box, if I can use the magnifying glass. So I'm not concerned with asserting anything else other than that at the moment. So it's specific, but you get to play around with what is more important. Yeah, exactly. That's a wonderful way to phrase it, Francesco. Right. I see Seraphim added an example. I will just move on to the next section so that we can work on interest and time, and then I'll also note down to some of your questions in the break. So throughout this lecture, we will have this case study. And the case study will be based on a banking application. So this will just be an example. I'll read through it. We have a background. So a financial institution is developing an online banking app for management, fund transfers, and bill payments. The testing team, following agile practices, prioritizes component testing to ensure the app's reliability and security. Now, the challenge for the team is that they must deliver new features quickly while maintaining the app's stability, security, functionality, especially for components handling sensitive transactions and user data. Now, what is the team's solution? They adopt a comprehensive component testing strategy using JUnit and Mockito to test controller services and data access components. So here we have the key steps. User authentication module. Component tests validate login scenarios such as correct, incorrect credentials, account lockout after failed attempts. So when we read through this, I want you to remember we're not talking about the connection between all of the login scenarios. We're trying to see, as you can see here, correct, incorrect credentials. So we're essentially testing a login form, which in itself is a separate component. So just to note that. Account transfer service component has verified fund transfer calculations, account balances, and error handling for insufficient funds and invalid accounts. So again, we are focusing on specific bits of the account transfer service, not going through each scenario that connects within it. Data access layer component has valid database queries and error handling using mock objects or in-memory databases, ensuring security against SQL injection and database issues. So we kind of see that all of these bits were actually tested in isolation. So nothing was actually mentioned here that everything interconnected is checked, and it will be in one of the next slides, let's say, of this presentation. However, we can see that the results from all of this is early defect detection. Now, this promotes a method called shift left testing, which says that testing from the get-go would save time and costs for projects. So we see that bugs and logic errors are caught early, reducing integration issues. So the component itself is actually the component tested gives us the issues that it has, and then when they're fixed, we have a bit less of testing to do in the integration since everything has been covered. Improve code quality. So having these types of tests encourage module and maintainable code since, again, um, it shows the issues, they are let's say corrected, and then the code is updated as well. Reduce regression risk, so preventing regression after code changes, obviously, and enhance security. Here we validated the security features mitigating vulnerabilities. So each separate bit when we were testing the database layer, the data layer was tested separately to see if these are all in check. So the idea I will once again mention is that it promotes component testing promotes reliability, security, and maintainability for this app specifically and for all. And it kind of starts the testing procedure as soon as possible, making sure that the issues are caught early on and that the code is let's say structured by following clean code principles. That is basically it for the case study. Do you have any questions regarding this? Okay, I don't see any questions, so I will move to the next bit, which is integrated testing. Now, integration testing, as we mentioned previously, is the type of testing that tests the connection between the components. And keep in mind, have in mind this little graphic. It's very good, and it actually shows a very nice pattern here for the types of testing. Is in a way the second test level that comes after component testing. Similarly to the component testing, it has a few steps that need to be taken, and they do differ but are similar in some ways. So when we go into it, we immediately see we have identify integration points. So check where the modules interact. These are the points when you will see that there is some kind of connection between two modules. So for example, we have product catalog with shopping cart. So when you select the item, it is added to the cart. That is the idea. That's how they are connected. When you search for a term, valid results regard to the term are displayed. Then we have development and test scenarios. So here we actually need to create scenarios that show some kind of real world usage. So here you would actually have, let's say, adding the item to the cart and going to the checkout. So this is a real world scenario. So these need to be created. Then creating test cases. The test cases go under the scenario. So the scenario is just, let's say, in a way, the flow, and then the cases. So what steps, inputs, and results are expected of that scenario. So what is supposed to happen? Then we have setup test environment. It's very important for integration tests to have this environment because you would most often mimic the production environment and do this on a lower, let's say, end, so like development or stage, where you would check whether this integration is successful. Execute the test cases. So this can be done either automated or manual. So this depends on the type of project. This is the type of test that most often QAs are associated with. So depending on the type of project, you can execute them manually, automated. And then you analyze the results. This is similar to one of the steps in the component testing to see if there are any issues. And if there are, document those issues and see what is the priority of going through all of them. Iterative testing and debugging. This means that once you have gone through all of the integration tests, you see that there are some issues, they need to be fixed. So afterwards, you will need to retest or re-execute the test depending on the approach and make sure that everything is resolved. Regression testing also falls into this category because once there was an issue related to some components of an entire integration, they make sure that everything is still intact after they are modified or when they are present. So making sure that nothing else has been broken. Final validation. Once everything is good to go, stakeholders review the results for final approval. So this is basically the idea of the integration test. Now, one thing I would add here on this level and the other levels, or mainly system testing level. There are things known as entry and exit criteria. And why are these important? Well, where you do this type of testing, you would most often need some kind of precondition to be fulfilled. And then you would also need to have some kind of expected result that will show you that the testing is complete. I see, I could see the question from Bibi. Could you explain what kind of environment, day and night? Yes, so the environment that I'm actually referring to um, is so let's take production. Production environment is what the users see, so the actual page. So what you need to do in order to test something as similar to that without testing directly on the page that the users see, you mock this environment. So you create, let's say, a clone of this environment, and you use that environment only for testing purposes. So this environment is usually called development environment or even staged environment, and those are only visible to the team. So you as a user could never access this environment. So it is the same page, but it is set so in a way that only you can access. You can even do this if your project, let's say, has a server. You go to the server, you have the page there, and that is completely isolated from what the users see on the page. So it's a, let's say, a place where you can run the same tests like on the main page, but on a different location in a way, or isolated from the main one. Hopefully that answers the question. Now, the regards to the entry and exit criteria. So as I mentioned, you will need to have some preconditions for when to start the tests and or how can you start the tests, and then when they have been completed. And why is this important? It's important because oftentimes you will notice you will have a let's say you will have a component that's maybe not working as expected, and then for you to test the entire connection from it to the other component, you actually rely on it. So when you would go to the development team and try to explain to them what is the idea behind it, you will tell them, so my precondition or entry criteria was that this is working, but I can see that there are some issues and I cannot, for example, when I select the result from the search bar on the e-commerce site, it's not saved in the cart. So I've added to the cart, but it's not there. So I cannot really test if I can check out the item. And that is the idea of entry criteria. So we see here, we have some examples like unit tested components. All modules must pass unit testing. This is a type of entry criteria. You can also make them more specific. So you can say modules fully integrated. All modules must be coded and integrated. So everything must be done in order for the testing to begin. Or you can state the search functionality needs to be modified in order to test the remainder of the site. So it is essentially what you need at that moment to start testing the integration, whereas the exit criteria notes when the process is complete. So successful integration, the application must work as expected. So everything, this is quite a blunt and straightforward exit criteria. Test documentation, all executed test cases must be documented. So it doesn't mean that only the modules work, but maybe the exit criteria for the project based on requirements says after you have documented everything, then the testing is complete. High priority bugs closed. This is quite a common exit criteria. So after all bugs are resolved and the software is working as expected aside of it, then this is moved to done and the testing is resolved, and submitting technical docs similar to the testing documentation. So again, entry criteria, what do I need to start testing, and then exit criteria, when have I finished testing? Do you have any questions so far? If not, then I will go to the question that we have here in the materials. So during the execution of your unit tests, you notice that one of the assertions fails consistently for a particular scenario. What should be your next step? So you can write in the chat 1, 2, 3, 4, A to D. So however you, okay, I see. A lot of you are already writing down the third option. Let's give it a bit more time so the others can answer as well. Okay. I see more answers related to C. Okay, I will now check the answer. Let's see, and that is the correct answer. So yes, investigating the cause and revising until the unit's implementation, if necessary, is important because again, we need to make sure and to see what is the reason behind it failing. Modify the expected output to match the actual output doesn't help. It actually creates a false positive. So the test is actually not working, but we're trying to make it work in a way. Ignoring the failed assertion, move on to the next test. If it's an important test, I mean, every test is important, so just ignoring them and moving on to the next to get a better statistic is not, yeah, B if you want to get fired, and disable the failing test temporarily until the issue is resolved. It's not ideal. You need the tests to showcase if the issue is resolved. So again, the one that makes most sense is the third one. All right. I will move to the next step, which is types of integration testing. Now, in contrast to component testing, here we have multiple approaches, just because we are testing a larger scope than just the components themselves. And I would say as a disclaimer, there is no correct or incorrect approach from the ones that we will discuss. You might notice that some of the types of testing are, let's say, more, let's say, not brutal, but more heavy in terms of having to cover a lot of things in the same time without some specific structure, but we will just see why those also work at given times. Now, the types of integration testing that we have are Big Bang testing. And Big Bang testing is a type of testing where you test all components and interfaces together. And basically, it might sound a bit messy because you are tackling everything at the same time. However, it does have a very quick implementation and does find defects really quick, especially large defects. The only challenges here are difficulty to isolate and debug issues and potential of conflicts between components. While the challenges here and the way of testing are evident, they might not be ideal. It is a type of integration testing that you would usually use when you have, let's say, a more unfamiliar application. Your job is to come and just find the main issues that you can discover. So just going through every aspect and testing based on experience in a way, doing exploratory testing, you will unveil some of the major issues that at that moment are the more important ones to fix. So you will be able to find those in the quickest amount of time possible, and they will be resolved as such. The drawback being you won't be able to maybe get to the root cause of each of those issues. However, again, the idea behind this is to cover as much ground as possible in the shortest amount of time and make sure that at least the larger defects are fixed. Moving on, we have top-down testing. I see one more question. If we know a test is failing and the fix is already planned, can be actually useful to circumvent the issue to test other. All right. So it's a very nice question. So it's not stupid at all. Um, um, it is actually an approach that you can actually go for. Um, the idea is that when you have a failing test and there is already a fix plan, you also need to make sure that, let's say, um, the test is also modified. So you need to keep it in mind usually how we go about it. For example, when we had one of our larger solutions, this was not maybe related too much to integration tests, but we had a specific scenario that was currently being worked on. We had it failing for a longer period of time. We put that test on ignore simply because we knew we were supposed to modify everything regarding the test, and we didn't have any information on what to modify yet. So it could be a realistic scenario at times, but it's not that common, I would say. All right. Hopefully that answers the question. Now returning back to top-down testing. So the idea of top-down is that you start from top-level modules, so the most simplest, the one that the users most often have contact with, and then you test from there to the more complex logic. Now, you might see here it requires stubs for lower level modules. This means mocks of APIs, and there might be a delay of testing for critical functionalities because the more uh, complex logic is on the lower levels. However, this type of testing is very good when you're more focused on providing a better user interface for the users of the page, and not so much in the, let's say, backend logic of things. So you're more focused on presenting the page in a good light rather than covering all the complex functionalities. This doesn't mean that it's only implemented when you do not have time for complex functionalities. It's just depending on the priorities. Its counterpart is bottom-up testing. So here you start from more complex logic or from lower level models and then move up the ladder. And then the idea is similar. So here you would mostly focus on those bits, and then as you go up the ladder, you would see, depending on time, maybe not cover as much ground as possible. And I would give an example here where in the previous, it is more common for front-end projects. This one is more common for back-end heavy projects. I would give an example with insurance companies. So they usually have these forms that you need to fill out, let's say, for larger clients, and then the clients don't really care about how the styles of the letters for the labels of the input fields are, or whether the input fields have a width of 120 pixels. So they are not really concerned with what the front end is. And when working with insurance, it's highly important that the payment logic works as expected, that everything that's processed is sent on time to the client because they're maybe working with larger sums of money. So that's where this type of integration testing comes into play more. Finally, we have hybrid testing. Hybrid testing is a combination of top-down and bottom-up testing. However, you start in the middle and then go either up or down the ladder. It's actually quite good for covering a lot of boundaries. However, it requires a lot of planning and coordination. This is a type of testing I would also recommend to do only when there is more than one tester, because that way is not only ideal, but you cover a lot of ground, a lot more ground than combining the other types of testing. But again, it requires a lot of planning. It requires a lot of information gathering. So knowing how everything will be covered in order to be successful, because again, you will be going into two separate directions and you will even be testing modules that are sometimes connected. So having this coordination and communication here is key. I'll once again note that none of these types of testing are incorrect or more, let's say, complicated than the other. It just depends on the circumstances of the team, the project, and the client requirements. So you can use any. It's just a matter of what is necessary and what is ideal at that moment. This part is earlier, but why not testing from left to right and right to left? Okay, okay. Fair enough. I thought it was a question. All right. Do you have any other questions regarding this bit? I see none. So then I will just do this one more exercise. So we have Frodo. He's a software tester, and he has been assigned to test a new mobile banking application. He decides to start testing from the top level modules, such as the user interface, main control modules, gradually moving down the lower level modules, including the data access layer and utility functions. Which integration testing strategy is Frodo most likely employing? You can write in the chat. Okay. So he decides to start testing from the top level modules and then gradually moving down. Take that into consideration. Okay. I see 3, I see A, I see 2B, which is the same. Okay. Wonderful. I believe he said he would take it. All right. I see a question from Valentina. Is it mandatory to know all these names, descriptions, approaches by heart, or will they be more easy to remember once hands and code? You don't really need to remember them by heart. We don't even discuss them as such when we're doing testing strategies. We might mention it once or twice. We're basically, you're going to mostly hear, okay, let's start from the front end or from the back end. So you'll mostly like see, you will see them in some shape or form, but you're not really going to talk about these that much and don't need to remember them by heart, definitely. Okay, so the majority said B. I'm going to check the answer, and that is the correct answer. So he starts from the top, moves gradually down. We didn't see any bit of trying to just cover as much as possible. So he did have some kind of structure when working. So it's not the big bang. He started from the top, so it's not bottom up either. And then he never actually went above or below at the same time. So he did not have to go a level higher. He only went a level lower. So that's why it is also not hybrid testing. So well done, everyone, for this. And I think we can leave this section for after the break. That will be basically all for now. So Jumana, you can
Yeah, Angelo, you can go ahead.
Okay, thank you. All right, I'll continue sharing my screen from where we last left off. So there we go. All right, great. Now, we stopped at the case study section of the integration testing. So again, we'll briefly go through all the steps so you can see what essentially is going on. You already know the background. Now the component testing is finished. So we need to ensure that the modules work together seamlessly. The challenge, team must verify the features like user authentication, account transfer, and bill payments, that all of them are integrated correctly and that they are functioning as expected across the entire application. So here are the steps that are used for the solution. End-to-end account transfer test. So this simulates a full account transfer scenario from user login to transfer confirmation, verifying both account balances. So we can see that in this situation was actually tested is the user login. So we have one component, let's say the user login, then they are trying to transfer something using other components, like let's say an input field where the balance is entered, and then that everything is transferred to the end. So we have multiple things that are actually covered and interconnected. We have bill payment integration test the entire bill payment process, confirming correct transaction processing and logging. Again, multiple singular components integrated with one another. You enter some kind of value within the payment process, you select the CTA to pay, and then you check whether that has been successfully stored in some database or whether you have received some kind of confirmation in regards to this. Error handling test, simulating failures like network timeouts, database errors, ensuring graceful error handling and data integrity. So this essentially makes sure that these in between that these errors would show some kind of appropriate message when failing. So again, they're connected to, let's say, this message model that shows that there is an error, let's say with the page, instead of just crashing the entire website. Now, what are the results? Validated functionality, same as before. So this assures that the interaction between the components is working as expected. So we do not have to have this in mind. We're going to the system testing. The issues that have been discovered are resolved. So again, adding to the build of confidence step, improved user experience. So once these flows are working as expected for the users, it will be a seamless experience since they will be going through all of these steps combined without any issues, and then continuous improvement guides ongoing refinement of the application. So once everything is done, it assures that when we go to the next step into the system part, everything will be prepared and we'll have some, let's say, let's put it as guidance toward what needs to be added and tested further. That is basically for this bit. Do you have any questions regarding the integration testing? I will ask one more time, or should we just move to system testing? I don't see any questions, so I will just move to the next section. All right, now moving on to the graphic, we went from integration to system testing. This is the next step. If you remember, we talked about the sequence, and the thing that you see right here is actually the most, let's put it, standard way of doing the sequence of testing. So what the system testing, as we mentioned, does, it validates end-to-end functionality. So the entirety of the system, all the interfaces, components, everything combined, basically doing an entire workflow of the application and checking whether it works as expected. Now, this type of testing is, I would say, at the more higher level, so it does require a bit more time, and therefore we need the other two unit or integration testing before, so that we can make sure that there is little issues as possible, so that we could save on time in this part. Now, similar to the other types of testing, we have some steps that need to be taken into consideration, and here we have test planning. For test planning, the idea is that you define test objectives, scope, resources, and timelines based on the system requirement and acceptance criteria. So you just test, you get which part of the system that will be covered, when, what is the expected outcome, what is the objective, and then you just combine them. And this planning does take a bit more time since everything is already there. However, it's not something that, how should I put it, is that detailed, since most of the bits would be tested by this point. Then we move to the test environment setup. Again, similar to integration testing, we're talking about an entire application that needs to be covered. So having the proper environment is necessary. So this is a, let's say, a standard step after the integration testing. Test execution. So executing the test to make sure that the functionality, usability, reliability, and performance of the page are there. So it's good to note that in this type of testing, system testing, we're not just checking for functionality, we're also checking for aspects that are not related to functionality, or rather to performance. So you can see we have functional testing, we validate that the needs of the system are met. However, we also check whether its performance, usability, security, and scalability are in check. So this is the stage of the testing levels where you would also perform load testing, security testing, performance testing. So how does the page work under a specific amount of users? How fast is the response time? So this is also covered within the system testing. And then moving on, we have regression testing. Again, after the integration testing, this also includes regression testing, meaning that when there is a code change, we have to make sure that nothing else is broken. We have defect management. Again, we have to note down any issue that we find and prioritize them based on the level of priority and severity of them accordingly. Now, here also we have test reporting. So after we have the results and the metrics collected from the entire testing, these are provided to the stakeholders, because this is basically the last step before we go into acceptance testing. And therefore we have the completion and handover. So once every defect is resolved and everything is working as expected, this is ready for acceptance testing, which we will see more in detail when we move to one of the next parts of this presentation. Now, what do we verify in system testing? Now, because we're actually going through the entire system, we are actually going for functional correctness. So what does this mean? Here's written verifying system performs all required functions according to specifications. So here you not only go through the requirements, you take the requirements from the stakeholders, the user's perspective as well. You take into consideration the functionalities and all the specifics connected to the components and the integration between them. So every functional aspect needs to be met. Non-functional requirements as well. As I mentioned, you need to make sure that the page is actually working at full performance, it's reliable, it's scalable, so even if a bigger number of users joins the page, it will still be able to maintain a balance and actually provide what the users would need despite the, let's say, large number of the incoming traffic. Interfaces. So this makes sure that the system has the system communication between it and other system is correct. So maybe you would have some third-party applications in regard to this application. So checking whether those interfaces are working as expected is also key. Error handling and stability, as we mentioned. So making sure that when there is some kind of error, the system handles it without crashing, meaning it might show some kind of message if a resource is missing and not just throw a 404 or any other type of message that would kind of make some kind of unease in the user. And relying back to the non-functional aspects, we have usability and security. So whether the user interface and experience is accessible and clear for use, and making sure that the page itself or the system is secure. So it covers all of these aspects, basically in a way as some of the aspects that we covered previously, in addition to some things that were not tested during the unit and integration testing. So if you notice, they kind of built up on one another, and there also Seraphim added a very good pyramid in which you can see how everything is structured in a way and how it leads to the next level. So I see a question here as well. So we actually do integration testing between previous integration test plus non-functional, if that makes sense. Let me see if I get this correctly. Yes, exactly. So what you're doing with the integration test, you're not really looking for the non-functional aspects. You're more tied to the functionality of the connection of those components, so for the flows. And then after you do that, after you complete it, you do the non-functional testing, which is tied to and everything related to the system. So once you have everything working as expected, that's when you come with the non-functional test, because otherwise results would not really make sense. They might fail. They might even pass if something is not added in the entire integration because there's more memory. So that's basically the idea. Yeah, it makes sense. Okay. Do you have any questions regarding to system testing? Okay, if not, I will move to the case study once again. So we're finished with the integration testing, and finally, we are focusing on validating the online bank's overall behavior and performance in the real world environment. So the team must ensure the application functions correctly, securely in a production-like environment. So this is key here. This is the environment that we mentioned that we will be using. This is a mock environment. So it's not the actual production, what the users see. Verifying that features like user authentication and transaction processing meet regulatory requirements and provide a seamless user experience. So here we see that the team has taken some testing tools such as Selenium, JMeter, OWASP to simulate real-world user interactions, and we're going to see in which cases that they have decided to do so. So we have functional testing. So for this bit, verifies all features, including user authentication, account management, transactions against specified requirements, covering positive and negative scenarios. So in this bit, essentially, we can actually relate the tool Selenium. So this is where you could write some tests in regards to these end-to-end scenarios. Like we mentioned earlier, you log in to the e-commerce web page, you try to add something to the cart, you add it to the cart, you go to checkout, you pay for it, and you try to check whether the payment has been processed. So this is the functional testing bit. In the aspect of the banking applications, we're working with the transactions. Performance testing evaluates responsiveness, scalability under expected and peak loads using JMeter to identify bottlenecks and optimize system performance. So performance testing, this is the bit, as we mentioned, that we are trying to see how well does the banking application work under a specific load. That's what you actually simulate with JMeter. We will have a lesson for this as well, and we'll see how we simulate the users there. But the idea is to optimize the performance, and this has been covered as such in this case study. And finally, the security testing, which shows vulnerabilities using tools like OWASP and validates access control, encryption, and compliances with standards like PCI DSS and GDPR. So this is more or less making sure that the web page is compliant and also if it's vulnerable. So this is more related to the non-functional aspect along with performance testing. And essentially what is done here, the system is made sure that both functional and non-functional wise, it is ready for use. So here are the results. validation of functionality. So the application is basically working as expected, both from user interactions, backend processing, so both functional and non-functional aspects of the applications are foolproof after the testing. Performance assurance, so the user traffic can be handled, security risk is mitigated, so we have performed this type of testing. And production readiness confidence, basically meaning that the application is ready for the handoff, so the acceptance test can commence, or rather the users and the stakeholders can give their input by going through what has been built and tested so far. So that is the idea behind the system testing as a whole. Do you have any questions here? Okay, I will move to the next section. And if, because I see some people typing, okay, do we make sure as testers that the laws are being abided to? Yes, there is. This is actually very important. We will also see it in acceptance testing. You do need to make sure that laws are being abided. There is this type of testing that is called legislative testing. You can also find a bit more detail about it in the ISTQB syllabus. And there is this whole process of where you need to make sure that what has been developed undergoes the regulations of specific countries, regions, states. So yeah, this does part. This is actually more, I would say, related to the entire team. So it's not that only the testers uh, um, have to make sure that the law is being followed. So everybody partakes in this. But as testers, we do need to make sure when testing, if there is such a requirement, to double check, because it could sometimes be something that's neglected, and that's another good practice, because if it does not abide the law, then the whole project kind of falls off. So hopefully that answers the question. Okay. Now, acceptance testing. No worries. Now, acceptance testing. This is the final bit of the levels of testing. And this is a critical phase. I would put it as a critical phase, not only because it is the part where the application is handed over to the stakeholders and users as well, but also it is the last part before everything is launched. So in a way, acceptance testing is like this gatekeeper of the application development and what the users will see from the application. Now, um, keep in mind that while we are talking about stakeholders and users testing scenarios, it does not necessarily mean that every application is given to users for testing. So often these user scenarios can be done by the development team, testing team. So it could actually be a group of people from the company that the stakeholders have, or essentially the development team, like a group of, let's say, the scrum master, business analyst, two developers, a tester. So it actually takes up multiple people as well that could provide some type of testing that is beneficial. Now, for that, we have different types of acceptance testing. And now we're going to go briefly through some of them, through all of them, and then more in detail through some of them. We have user acceptance testing. This is the most common type of acceptance testing. And it is conducted by end users to validate that the system meets business requirement and is ready for production. As I mentioned, these end users are not necessarily just the users that see the application, and can also be a team of individuals, either from the client side or from development team. And we will talk about more detail on this in the next slide. Alpha testing, which is done by the internal development team to make sure that there are no issues before beta testing. And then we have beta testing, which involves external users that provide feedback to showcase some hidden issues before a bigger release. You might have heard of alpha and beta testing in regards to video games, computer games. They're most common there. So the idea is that in alpha testing, it's only the team and maybe a few selected individuals. And then in the beta testing environment, everything is done by play testing, or actually testing with external users. So the game is kind of launched, but when you try to play it, you will see that there are a lot of issues. And usually that is the idea. The issues are there so that the players can also provide input about those issues. uncover hidden issues and also give their experience, maybe performance-wise. They were having frame drops in specific scenarios, so that's why these types of testing are very important. Business acceptance testing, ensuring that software aligns with business goals of the product owners. Operational acceptance testing, that the operation aspects like backup procedures, system maintenance are there. I would give an example for, let's say you have for your, let's say, web page, you have a load balancer that is, let's say, a system that if you have too much people on your server, it will forward the other users that make up the extra amount to another server that you're using for the page. So you're checking whether this handling is actually working as expected so that people are being forwarded to the appropriate, let's say, instance of your page. Contract acceptance testing, checking compliance with contractual requirements and specifications. Regulatory acceptance testing. So this is with industry regulations, crucial in sectors like healthcare and finance. So this is what I was referring to back previously to the question we had regarding do we have to, as testers, see if the law is being followed? So the question that you, Susan, had earlier. So compliance regulatory testing, you need to make sure that everything is in order. So again, it's not specifically tied to testing, but the whole team has to be aware of it, but we need to do and recheck it. Yes, and then compliance testing confirms adherence to internal policies and standards more related to the client itself. Yes, rat cat bad, exactly. That's a good way to remember them. And I would also note here that well, you might come across all of these types of acceptance testing. The most common ones are user, business, operational acceptance testing, and then the others are more related to, let's say, more industry-based. So alpha beta testing is mostly done in games. Regulatory acceptance testing is with more the financial sector or healthcare, so where there are a lot of things that need to be followed thoroughly. So you would see these are, again, dependent on project, but some are present on mostly all. Now, choosing the right type of acceptance testing mostly is related to the project and the client's needs because they will be taking part in this. However, there is also the options as testers to provide, let's say, support in making the decision of which one would be the ideal type of acceptance testing. Usually the common practice is user acceptance testing with business acceptance testing. However, it is always our job as testers to give let's say, a suggestion, and it could be adopted if we see the need for it. Now I have a question. Let me just see. We have a question now. Based on your experience, what is the more problematic testing phase? Meaning where the project can halt or be sent back for redevelop and retesting. Given that if we use an agile approach, every phase can be the problematic one, but talking about real experience out here. Oh, well, from my experience, it's a really nice question. The most problematic, and I think most of you that have worked with clients could maybe see that perspective and agree with it, is the acceptance testing. So when you're working, usually when you're working on most projects, you would have requirements ahead of time, which you have discussed with the clients thoroughly many times. So they have been discussed, and most of the time the clients will either not be listening to you or just not even take notes and forget completely everything that was discussed. And then in the meantime, they might get another desire for how something should be made, but they never communicate with you. And then when you get to the acceptance testing bit, what happens is they go through the application and they start saying, oh, this is a bug, this is an issue. How can you let this go to this stage of the product? And in reality, it's you have followed every requirement, you have followed every decision that you've made together. But whenever you had questions sent to them or asked during meetings, they either have not, they've never either reviewed it or they didn't even listen. So now when they decided that they want to make a change, in a way they're not agreeing with you where you're in the right. So most often it's acceptance testing because you will see more often than not, they will have so many suggestions that will change the component test, the integration test, the system test. So it's definitely this phase. And I'm not saying that all clients are like this. I mean, there are scenarios where this phase is flawless, everything's working as expected, but more often than not, this is the kicker, I would call it. So this phase currently. Um, uh, the ideal way that this can be avoided and what we have adopted more recently is making the recordings of the meetings. We stopped sending notes because they were ignored completely. Testing reports and everything was, well, in this specific scenario, ignored. Um, and what we did was we just sent out the recordings that they had. And then when we would come to this scenario, when they would say, oh, but this was not uh, mentioned here, we would just refer back to the recording. And our manager at the time would also pull up the recording even while we're at the meeting. And we had like these threshold points on them. So they would just go to that and say, this was the decision we made. And oftentimes they would just be like, okay, yeah, that works. So I believe having the recordings and giving reference to them is more effective because I think they have a better time of just listening afterwards, because oftentimes the clients um, are not only concerned with the application development, they have other tasks. So the recordings were what worked best for us, I would say. Uh, I wish I worked at Blizzard, but yeah, I would say that is the ideal a bit. No worries. Okay. A software company is about to release. So we have a little question here, so we can go briefly through it. A software company is about to release a new mobile application to the public. For the official launch, they want to gather feedback from a selected group of external users to identify potential issues. Which type of acceptance testing should the company conduct? Yes. Okay. Thank you all. All right. I see beta testing B. Okay. All right. I see plenty of answers going for B. I'll wait a bit, but all right. Wonderful. And that is the correct answer. So we're dealing with an external users to see what issues they could find and some constructive criticism. So it's definitely beta testing because it's the one related more or less to the external public. So well done, everyone. And thank you for the great questions actually for this section. Um, if you have any additional, I'll see to them at the break. Okay. Moving on, how user acceptance testing works. As I mentioned previously, this is the one that you will 99% of time use on every project. It's quite common and it has a few steps before it can be implemented. Now, the steps to conduct this type of acceptance testing are the following. Conduct product requirement analysis. So first you would need to go through everything that was required, usually through user stories that are well defined ahead of time, and see what are the software requirement specifications, what are some requirements provided strictly by the stakeholders, what are some features, what is the business objective. So just simply going through the documentation to make sure what needs to be tested. Then opt for a suitable methodology. Now, when you have two types of methodologies, we have waterfall or agile, it's very different how your approach would be. If you have waterfall, the user acceptance testing occurs at the very end of the cycle. So after everything is developed, everything is pushed, you don't do any testing in between. So this is at the very end. And in agile, contrast to this, it's actually with iterative testing. So there's some kind of development, you do acceptance testing, another bit of development, you do it. So you need to make sure you decide which methodology you go for. In most recent days, it's agile. So it's very rare to see the waterfall methodology implemented because it's not as, I would say, robust as agile, but it could be a possibility that you could also see it. Then building the right user acceptance team. As I mentioned previously, it's not necessarily external users that do the user acceptance testing. It could be a team of, here we have testers that could represent the target audience. It could also be business analyst. It could be a project team members. It could be somebody from the client side. So just taking a good portion of people that will be going through the scenarios to cover as much ground as possible is ideal. Set up the required testing tools. So depending on what are the needs at the moment. Setting up user acceptance tools that facilitate efficient testing processes is key. So you might need some additional tools. Maybe you're testing some APIs along with the other members of the team. So having Postman, for example, for that would be useful to conduct these scenarios. Again, depending on what the project needs. Create a proper test environment. The most important bit maybe here is to have the proper test environment. So um, the idea is that everybody would want to simulate as close as to the production. So they would, if the stakeholders are taking place or somebody from their side, they would want to be most of them. They would like this to be on production, but because usually the testing does not occur there, you need to have as similar as possible environment to that. Then the execution of the testing process commences. So the scenarios that have been defined are executed by the people who are taking part in this. Then the information is collected from everybody who took place. So there is this feedback that is provided from everyone's side. This could get chaotic from time to time. So people would like to have like this group chat, which has been the case on one of my projects. And then everybody just writes all the issues that I've gathered without combining them and adding them to a structured document. So I would also give as a tip whenever you do this type of user acceptance testing and you are the lead in this process as a QA, always make sure to provide a sort of template document where you would want people to add everything that they have discovered, and then just to have it as structured as possible so that it's easier for both you and the development team to take a look at what has been tested, what were the steps, and then what needs to be modified. So having a good way of collecting and structuring the information is key so that you don't get in a scenario where you can't even remember if you've collected and covered all scenarios. Finally, fix, retest, and launch. So address the identified issues with the development team. You get what needs to be covered. So this doesn't necessarily mean that these issues are bugs or defects. It could also be some constructive criticism, so that needs to be modified. That's why I mentioned this could tally it back to one of the integration or component testing tests that would need to be modified because maybe some of the users are not satisfied with the specific interaction between two components. So it could occur at any stage. So fixing, retesting, and making sure that everything is all right afterwards is the final step, meaning that the product is ready for launch. I see a question from Susan. Will user acceptance testing be repeated too? Um, well, not really. When you cover the scenarios at once, so the idea of the user acceptance testing is not similar to standard, let's say, regression testing. So you test everything again that was connected to the issue, but rather once you are at that phase, you do the user acceptance testing, you find some things that need to be modified. You usually focus on them after you have completed it initially and have done the fixes because usually the bugs and defects connected to user acceptance testing are not, how do I put it, of a high importance. So they are not very critical bugs or issues. Usually it's just some slight modifications. So you don't really need to go too much into detail and cover everything again. Just the things that were modified is enough. Yeah. Okay. Any other questions? I see no other questions so far. All right, then I will move on to the I just want to check. I might have missed. No, it was okay. All right. Finally, we move to the case study bit for the acceptance testing. So now we have finished everything in regard to the system testing, and acceptance tests need to be done to validate that the application meets the stakeholder requirements and it's ready for deployment. Now, this phase tests the application from end user's perspective. So what is the challenge? The team must gain stakeholders' approval and ensure the application meets business requirements and user needs. So what are the types of testing that have been done, and how does this approach been resolved? The team collaborates with stakeholders, business analysts, product owners, and end users to define acceptance criteria and scenarios. So we see a lot of people are involved, which are not necessarily just the end users, and they employ manual and automated testing techniques to validate that the application meets specified requirements and delivers value. So here we have what were the steps. User acceptance testing. So this obviously by now we know that's most common, it's word. So with this, the team with the end users interact with the online banking application and perform common tasks like logging, transferring funds, providing feedback on usability and functionality. So again, we want to make sure that everything is working for the end user stakeholders, so these needs are met. Then we have regulatory compliance testing. So this testing is done to ensure the application complies with industry standards and legal requirements. So this is the one that we previously mentioned. Do we abide by the law within our application? So this is the idea of this type of testing. Again, the whole team needs to follow it. I will mention it again. And we as testers have to validate to make sure that everything follows the policies. Finally, operational acceptance testing. So this is in order to make sure that the application is good to go for deployment and maintenance. Again, if there are too many users, we want to make sure that the number of users is balanced, that the application is not crashing in this sense, that the weight of users is distributed among the servers that the application uses. And we also want to see how the monitoring goes, are we showing the correct metrics, so on and so forth. So by doing all of these types of acceptance testing, we result with stakeholder satisfaction. So once we've met all the requirements, once the stakeholders can see that that everything is going according to their plan, that the user is satisfied, it means that they will also be obviously satisfied with the result, that the application is compliant with regulatory needs, so that everything is working according to the industry standards and there are no legal risks. Again, this is very important because we do not want to, because the application could have a massive failure if these do not comply. Finally, operational readiness. The application can be effectively deployed and maintained. So this can be handled moving onward due to the types of tests that we have covered here. Do we have any questions so far? Okay, I see not, so I will move to the next section. So when we were at the beginning of the lesson, I mentioned that there is a sequence of how the test levels go. And this page here will showcase how the actual relationship is between these types of testing and a specific order. Now, before we go into detail into this graph here, what is the idea of the comprehensive testing framework? Now, the idea is that, as we talked at the beginning, you break down specific parts of testing into different levels, and then you perform each to make sure that the job is easier for the next. Then that makes it easier for the next, all along while coming up to the acceptance testing, where you should have a fully functional application that meets users' needs, that might see some different aspects that need to be tweaked. So the idea is you don't want to go to acceptance testing with critical issues displayed, and that is covered by having these levels all together. So we see that together these levels detect defects at different stages of the development lifecycle, ensuring the software adheres to quality standards and user expectations. So I'll move back and showcase this with a simple example. So let's take the e-commerce web page that we have, let's say Shopify. So first off, you have unit testing. So first, we tested the components in isolation. So simply testing whether each component works as expected. We test the filters, the search box, the cart, login. So we test all of these separately. So now we know, okay, everything is working according to plan regarding the components in isolation. Now, let's see how these components work together. So if I try to log in and click on the login CTA, am I redirected to the correct page? And can I see my, let's say, first name and last name? Do I have my address integrated? So if I log in and go to the Shopify search result page, select an item, is it added to the cart? So now I made sure that the connection between all of my components that have already been tested are working as expected, and essentially I have the flows built in successfully. So now I don't need to really retest any components. I just simply focus on the interfaces between them. Now, once I've done that and I have both components and the interfaces, so interactions between them, I move to system testing. So now I can perform the end-to-end test, or actually log in from the beginning, select an item, add it to the cart, go to the cart, check out the item, pay for it, and get a confirmation. So this entire thing I can just check. I can check other scenarios as well, meaning I do not really need to focus only on interfaces or components, as those are done. And here my job is related for end-to-end scenarios. And now, since I've covered them as well, the interfaces between components and the components, what I'm left with is the acceptance testing. And the acceptance testing is the very last bit. So as I mentioned, you do not want to have crucial issues or bugs that appear for the acceptance testing phase. Again, there could be some issues that do appear, and it is not something that's not normal. Again, you cannot really remove all bugs from any system. However, the idea here is more that requirements are met, that users are satisfied with what they're seeing, that the speed that was previously discussed about for the application is correct. Does it need to be a bit faster? Are they able to use the page while having a faster amount of them on it? So this is basically more related to feedback, to constructive criticism, and of course, finding some minor issues that, depending on where they are found, they can be traced back and fixed within one of these types of testing. However, the idea is you do not need to do all of them together at the same time, which will be costly, which will be very time consuming, and will not result with the best quality since, again, you won't be able to really focus specifically on each part simply due to the vast amount of testing that will need to be covered and the amount of data components and integration with it. So having this sort of flow is ideal simply because you break down everything, you test into chunks, and then when you build those chunks together, you get a very nice high quality product. So that is the idea of what is the relationship between them. Do you have any questions regarding this? Okay. I don't see anybody type. I see Susan typing. All right, I'll move down and then get back to the question if there is some, because we have a little challenge here. So challenges, we have an order of levels of testing here. And what we have component acceptance, integration, system testing. The idea is I will pull them down to this section. And all you need to do is give me the order. You can write them like, for example, okay, you already started putting them down. Wonderful. And then I will drag them accordingly so we can see if that is correct. I already gave the answer away maybe through the explanation, but let's see. I'll wait for a few more answers. I see a +1 for the answer to Jordan. That's a very nice way of uh, simplifying that. Okay, right. I see already a pattern, similar one being added. I give 2 more minutes. Okay, more people are typing. I see that we have already the standard scheme, so I will draw and drag and drop them here. First component, then integration, then system, and acceptance testing, and see that that is the correct order. So well done to everyone. I'm glad that you were all part of this activity and that you get the idea behind the levels of testing and the order in which they go on to. All right. Now, before we move into the maintenance testing, we have one more section that we need to cover, which is very good to know as an extra knowledge. That is the pyramid and quadrants. Now, what I want you to take away from this section is that the test pyramid and test quadrants are not something that's going against the testing levels, but are essentially these are two models that support and help organize the testing levels on certain projects. Now, the models themselves, the test pyramid, is a model that focuses on test granularity, automation layering, and cost efficiency. Basically, this model tells us how much of each test should we use, and we will see in the graphic a bit below. And then the testing quadrants help teams align test types with technical and business goals. In short, which tests should be used and why, basically. So we will see this in more detail moving forward, starting with the test pyramid. Now, you see here we have this graphic where we have unit, service, and UI. Then we have this that shows a tortoise and a rabbit. This is just showing what is the speed of each layer. And then we have the cost of each layer. Now, what is the idea of the testing pyramid? The idea of it is at the bottom, you have the fastest and the most cost-effective types of tests, which are unit. Now, why are they at the bottom? Well, they are all automated, they run very fast, and they do not require any external systems. Remember, we mentioned that these tests are only components in isolation, so you don't really need any type of interface, meaning that the test execution here would be absolutely very fast. And then the feedback that you get from them is quite fast. So you get a result based on the test quite easily and quick, and you don't have a lot of maintenance. And they're also cheap. So hence they are at the bottom. So they are the cheapest, they are the fastest, and you do cover a lot of ground just by going through the components. Then we have the service area, which is in the middle, and this is essentially integration. So we have this layer as well because with unit tests, you don't really test the interfaces. So you need to have an option to catch problems that you couldn't with the unit tests themselves. So while they are a bit slower than the unit test, they're also quite faster than the one compared into the UI, as well are a bit more cost effective because again, they can be automated, so they do not take up that much time, and they also cover ground that the unit test cannot. So that's why they are in this area. And then the UI is comprised of the system and acceptance tests. So these are the slowest and by far the costliest. And why is that? Well, when you do system testing, as we mentioned, do end-to-end tests. So this covers a lot more ground. You're actually going through an entire flow and a number of flows, as a matter of fact. And the idea here is that those are a little more time consuming, even when they are automated as well. And if you go and look at the acceptance test, you need to make some kind of team that will go through the application, that will test specific user requirements or stakeholder needs. So again, a lot of time and a lot of cost because it takes a lot of time in itself. So that's why this layer is at the top. And the idea here is that you want to have a lot more automated tests at lower levels where they're more cheaper and stable because again, you're focusing more on specific components and on the integration between them, and then limiting complex UI tests to only what's necessary. So you want to make sure that you cover as much ground as possible with the component integration test, and then when it comes to system and acceptance, you need to have something more or less stable and working so that the issues here would be more low level based and will be more focused towards the requirements. Okay, I see a question, but Seraphim, you tend to it. I'll leave it at that for now. So that is the idea of the pyramid. So you have most automated test unit at the bottom, fastest, cheapest, cover good ground, integration test or service in the middle. Again, quite fast, not as the unit test, but cover the ground that they don't. And then the UI, just automate what is necessary and try to keep it as simple following user requirements. Okay. Now, let me see if there are any questions just briefly before we go into the quadrants. Additional to design component. Yes, I see, Valentin, your question. These are, and these designs, these two designs, actually overlay the levels of testing. So the idea behind the quadrants and the pyramid is to help you understand what you need to implement in the project. So how much tests from which level, and to understand which tests you need to do to, let's say, critique the product or to support the team. So we will see again with the quadrants now as well. So regarding the quadrants, what do the quadrants do? They make sure that the test strategy of a team is holistic and purpose driven. So what is the idea here? You see that we have this little graphic here. And mind you, before I want to mention, these quadrants are not in any specific order. So it's not like you have to go Q1, Q2, then Q3, Q4. The idea here is to understand which tests fall into which quadrant and what do they do. So in the first quadrant, we have unit tests and component tests. These tests are technology facing, so more towards the tech perspective, and support the team, so the development team. These are automated, so the unit tests, component tests, however you want to mention them, are all automated and they all fall into this quadrant. They run throughout the entire life cycle of the application. So as I mentioned, they're not before or after some of the other quadrants, and they're integrated into a CI/CD pipeline to ensure that every change is addressed and tested. Then in Q2, we have functional tests, examples, story tests, prototype simulations. Now you see here, this is business facing and supporting the team. This can be both automated and manual. So this is usually where you will find the integration tests and system tests. So the idea here is that you are checking the functionalities in between the components. You can do that both manual and automated. You can use tools such as Selenium to automate tests between to check the interfaces of the components. And it's also business facing because you're also going through some of the requirements in order to make sure that these interfaces are working as expected. Now, when you go to Q3, you will see exploratory testing scenarios, usability testing, UAT. In this quadrant, it's business facing and critiquing the product. So this is where acceptance testing falls. So in this specific quadrant, you would actually do everything manually because you are following some kind of requirements. And then the usability testing bit also comes into play because the users would come to the page, they would see what they like, what they don't like, what issues they have found are more important to be handled. Same goes for the stakeholders. And that's why this is business facing, again, because it's more related to the stakeholders and it critiques the product from both their and the user's perspective. Again, this is also manual. Finally, Q4, performance load testing, security testing. This is more focused towards the technology and critiquing the product. So this uses various tools. We mentioned JMeter previously, some security testing tools as well, and critiques the product in a way that it says this application is stable or it's not scalable, or maybe the response time is good when there is a certain amount of users. So that's why this is critiquing the product, so not necessarily supporting the team, and is technology facing since the load testing tools are more used than not for this specific quadrant. So that is the idea of these four quadrants. And put simply, we have this little summary here. With Q1, you want to stabilize code early. With Q2, you aligned with user stories. So you do the testing with manual both automation included. In Q3, you explore and validate user experience, so what you can improve from that perspective. And Q4, to make sure that the performance, security, and reliability of the page are on the highest level. So once again, I will mention, these two are not design patterns that are going against the standard testing levels. These are actually used to overlay and support the testing levels and give you a better idea of where and at which point which test can be included, so that when you're working, especially at the start of a project, you will know how to organize each bit better and then have a better structure moving forward. Do we have any questions? Okay, I see a question from Valentina. Is like to choose between waterfall, hybrid, agile DC, or all levels are to be considered used? Um, uh, so I see another question. Checking the mirror board, I don't understand the difference between the left and right test levels. So I will try to explain this as simply. So the test levels standard test levels are the component integration system and acceptance testing. Those are test levels. And then the design pyramid and the quadrants are not test levels, they are patterns. They're design patterns in a way. And they support the levels. So they're not really additional test levels, let's call it. They're just patterns that you can use with the levels. Yeah, no worries. Any other questions? I don't see any additional questions, I think. So if that is all for now, I think we can move with the final break. And yeah, you can take over for now.
Angelo, you can go ahead.
Thank you. All right. I will continue to share my screen from where we last left off. Okay. Let me just check if everything is okay. Yeah. All right. So the final part before we move into the lab, and this is not so much a test level, it's a separate bit, but also is important, and it kind of goes in accordance after all the levels have been completed, and that is maintenance testing. So what is maintenance testing? Well, after you have successfully launched an application, as it functions moving onward, it would need to have specific modifications, or there could be issues that arise that have not been detected prior, and testing is required to be done in these scenarios. Now, maintenance testing essentially um, uh, is divided into two categories, those being confirmation and regression maintenance testing based on the nature of the testing done. The difference being, for confirmation maintenance testing, you focus on making sure that modifications or fixes made to the software are working as expected. So this is the only focus that you do. So you're just testing what was modified or what was fixed, nothing aside from that. And we also have an example here with a banking application. There are updates, updates its interest calculation model, and then the testers try to simulate scenarios that are including various account types and interest rates, confirming accurate calculations post-fix. So as we can see, we are only working with this specific part that was modified. Now, regression maintenance testing ties back to the definition of regression. And the idea here is that there are no additional defects introduced due to some kind of modification. So let's say we have a modification that is made to the filters of an e-commerce site. We want to make sure that because we did that to the existing filters, there are no issues introduced to the search results view or to the search itself. So we're just trying to do some regression after everything has been completed, hence the name regression maintenance testing. So again, the difference between the two. With the confirmation, you really just want to make sure that everything is working from the modification. And then for the regression, you want to check bits that are, let's say, not directly connected with the modification, but we want to make sure that they are not failing after the fix or the change has been introduced. Okay, so that is the idea behind these two. So do you have any questions here? Um, Anything that's uncertain? All right, I can see there are no questions. Then I'll move on to the next bit. Now, what are some of the challenges and strategies? I can say from my perspective, working with an application that we more or less had were introduced as a maintenance team, the biggest challenges that you will face in testing would come from maintenance, be that just maintaining automation frameworks. It is also, I just see a question. This is effectively hot fixes. Um, hot fixes in a sense are things that need to be addressed and either change or fix immediately. Um, it can also, this is more related to just working and testing features added to the application after launch. So it doesn't necessarily have to be a hotfix. It can actually just be an additional requirement from the client side that it's not something that needs to be done ASAP. I could tie this to the example that I was saying. We were working as a maintenance team of an application, so we did have frequent changes to the page, which were with certain dates, but were not, let's say, strict that they have to be done by tomorrow or the day after. And we also had hot fixes. And yes, you do maintenance testing for hot fixes as well, where we would have some urgent issues that we need to tend to at the exact time. So it's not effectively hot fixes, but it does cover hot fixes would be my answer. So hopefully that's all okay. Now, what are some challenges and strategies? The challenges are listed here. One is understanding legacy code. So what does this refer to? Complex, poorly documented legacy code makes it hard to understand functionality and dependencies. This is a case that we had on my previous project. So the code had functions that only had one letter, so they were not descriptive. And oftentimes we would find ourselves going through scenarios that we couldn't really understand how they were functioning and what method was called so they could be executed. And the strategy that could be used to mitigate this is to use code analysis tools to reverse engineer legacy code, document dependencies, and create comprehensive test suites. We essentially did this. We actually even added our own solution and migrated the specific parts of the solution, of the old solution to it, and then refactored, recoded, changed definitions, and after moving on from the project, everything is still not fully modified, but it's definitely in a more working and stable, let's say, area than it was prior. Regression risk. So changes may introduce new defects or regression in existing functionality. So this is always a risk when working with, when maintaining anything. And the effective strategy is implementing a robust regression testing with automated test suites and prioritize tests based on criticality and impact. So this is more priority and severity. We will talk about this in one of the upcoming lectures, but yes, this is an effective way to mitigate the regression risk, because with automated tests, you definitely won't need as much time and manual effort when doing the regression, and it is in a way to make sure that changes that will be addressed later on will be checked in the general functionality. Maintaining test data. Test data becoming outdated is nothing new. So credentials are often in most systems updated regularly. So this is not something that is uncommon. And the way that this is mitigated is either you have like this, you have some kind of test data that you mock and that you make in a way that it could be reused constantly. So you kind of like go through the moment, or let's say break the moment of that always being updated, or this falls under the generation. So for synthetic data generation, that is one way, or just constantly updating the data is also one type of solution that you can do if you want to go into full security, let's say, support. So these are two of the ways that you can go about this. Then we have compatibility and environment issues. Changes may cause compatibility issues with different operating systems, browsers, third-party integrations. So this is something that you would notice, especially in automation test suites, because you would have these so-called driver updates. And sometimes when this is not, the driver is not the same version as the browsers, you will not be able to run any tests. So that's why you can conduct compatibility testing across different environments, maintain a matrix of supported configurations with regular checks. So make sure what versions you're using are compatible with the versions of the operating system, the browser, essentially to make sure that everything can be executed and everything can be deployed. Change impact analysis. So this is assessing the impact of changes on existing functionality can be challenging. Basically, you need to always make sure how the changes will impact what you already have. So you need to use this technique to see whether um, uh, to see what changes can be implemented at what point and what is the impact. So how heavy would the impact the overall flow of the application? And this is actually quite challenging. It requires a bit more experience, let's say, multiple fields, so that you can have a vague idea of what the impact could be. Moving on, we have resource constraints. So limited resources can hinder effective maintenance testing. Again, this is obvious. It is not only tied to maintenance testing, but it is one of the issues. And in this scenario, you can prioritize tasks based on criticality and leverage test automation to maximize efficiency. So when the resources are limited, you need to have a very good sense of prioritizing what needs to be assessed first, and just having automation definitely helps you within that strict frame. Finally, communication and collaboration. Lack of communication between teams can lead to misunderstandings and delays, especially when working with maintenance, because obviously you need to be updated on what changes are happening at all times. That's how, when we worked in the team, we had this sort of working known as Kanban. So in a way, everybody was informed on what is happening, be that through the tickets added or comments. So we were more or less all the time in the loop. Otherwise, when we were not, it was not functioning as expected. So this is actually part of the foster culture of collaboration with regular meetings, knowledge sharing, and documentation to ensure alignment and transparency. So the tickets, comments, tracing back to that, and having a lot of meetings, especially with the clients, did help with this a lot. Do you have any questions regarding this section? It was more or less just some challenges, common challenges that can be seen. Okay, if not, I will move to the final bit, which is maintenance testing long-term plan. Now, essentially, when you are working in maintenance, so not just maintenance testing, just overall maintenance of an application, it's really important to have effective test strategies for long-term maintenance. What does that mean? You want to essentially plan out how you will be covering all the changes, modifications, and fixes, have some kind of process in play, similar to how you would have throughout a software development lifecycle. So here, what you can have is assessment of existing systems. So evaluate what is the architecture, dependencies, critical functionalities. So make sure what scenarios are the most important, the ones that are maybe the most often used by users. So have an idea of what are these, let's say, threshold or the threshold points. Establishment of baselines. So set performance and functionality baselines as benchmarks. So what are the, let's say, bare minimums to say that the page is fully functioning? So at what speed, at what load does the test work? So then you can compare it to if it needs to be increased for specific launches, or you can just have it as a reference when going later on for big releases. Creation of comprehensive test suites. So having suites that cover functional, non-functional, regression, smoke, integration testing, multiple types of scenarios definitely helps, because you would have, let's say, a suite for any scenario. So if you need to perform non-functional tests or performance tests, rather, you can execute only those. If you need to check whether the existing functionality is working after a change, you run the regression pack. So you have this sort of arsenal of tools that you can utilize to make sure that good maintenance is at hand. Implementation of automation. Obviously, the automation testing helps out, again, reducing time, manual effort, and helps with the regression, smoke, and performance tests greatly, since you would not need to run them all the time by hand or just executing the scripts. This does take a lot of time. So having automation really helps out in maintenance. And I see a question: how often does it happen that a company wants a software developed, tested, but not maintained? Maybe with small companies, small groups, single individual, even though I imagine maintenance is usually included in the contract. Well, it depends on what kind of software the clients want. And I would say, because I have worked in mainly a corporation, the clients that we have had usually have had contracts for development and maintenance. But I can say that for the current project that we are working on right now, it is a very big cloud project. And due to its vast size, they need a lot of teams to just develop features, and that is that. So there are scenarios where you will only need to develop a specific part, feature of the project, however you like to phrase it, and you just put it into the entirety of it. And then you don't do any maintenance. So this maintenance will probably be done by either the client entirely or somebody, some other company maybe with who they also have a contract for this. But yeah, that's the idea of it. Yep, no worries. Moving on. Continuous monitoring and reporting. So you need to have some kind of mechanism that will monitor performance, detect anomalies. This does play part in testing, but this is usually handled by infrastructure teams. So they do have these types of monitoring reporting capabilities. And then you can also read through them, compare them to some baselines that you have set up. So that is the idea behind this. Then we have adaptation to change, so remain agile and update test strategies based on evolving needs. Again, you want to make sure that you update the test strategies constantly, so not just focusing on the ones that are always there, because they can get redundant, so unusable in the future. The other parts are collaboration, communication, which we already went through, how effective it is. We have investment in training and skill development, which I would like to highlight. So as testers, you're not only required to just use the skills that you already have, but having the ability to have some trainings within the team and learn new methodologies and tools will be very effective when working on maintenance, because you will be up to date with tools. You can even implement something that's more efficient than the ones that you currently have, which happened on one of my projects where we changed Selenium with Playwright for running smoke and regression scenarios due to having a lot of tests failing due to waiters. So we had the training, we were able to implement it, and the result was having a speed of execution test doubled in comparison to Selenium. So definitely is worth it. Then documentation and knowledge management. Having good documentation is not only necessary for you while working on the project and maintaining it, but also for people to come to that project so they can have an easier time of being integrated and, of course, going into work as soon as possible and understanding the basics. So the documentation that's provided by the testing team is, I will also say, the most important, because more or less we have the most knowledge when it comes to these areas. So due to the fact that we always click around and execute the tests. So having a good documentation from our side helps everyone on the project. Finally, regular reviews and audits. This does help with going through some of the things that are changed and that are either added as modifications or issues to the application itself. So having this is kind of intuitive through the entire process. That's basically for long-term plan. Do you have any questions, or can we move on to the lab exercise? And remember to record them. Exactly. That's a very good catch. Yeah. Reviews, audits, review. Key. Okay. If not, I will be moving to the lab exercise. So thank you for bearing with me throughout this phase. Now we will do a bit more of an interactive exercise. So we have this they have this exercise where we will have you all divided into multiple groups, and each of you will be assigned unit, integration system, or acceptance test. Now, you will need to go to this site, the internet testing site. I will also leave a link in the chat here, and you will have some challenges that you need to complete. So if you're in the component testing group, you need to test the individual components like checkboxes, drop-downs, drag and drop features. You have tasks that are listed here, and then a specific goal. So you will need to go through the tasks, checkboxes, drop-downs. You see verify, checkbox, toggle, confirm. You can discuss how you want to go about it within the group. And then you have a goal to, for example, identifying issues with isolated components functionality. If you're in the integration testing, you have different tasks, you have a different goal. Same goes for the system testings and for the acceptance testing. So the idea is you will have breakout rooms. You will all be assigned a specific area of testing. And then once we are finished with the breakout groups, we'll come together and we'll present what goals were reached, what were the outcomes of the testing of the separate groups. Is everything okay? Do you have any questions regarding this? If there are no questions, then I would say we can go ahead with the breakout groups. I would say we have about, let's say 12-ish minutes. So then we can regroup and go through the middle together and the goals. So, yep, I think that is basically it. And you can go into the groups and discuss and go through the scenarios.
And so you can go ahead.
Yep, wonderful. Okay, so I will just share my screen once again. I don't think we needed that much. Okay, so what is the idea? So we've completed all the scenarios that we were given. So now what I want us to do is each group, it can be one person or however you wish, to write down what was the goal, what did you experience, what did you see? So did you find any issues maybe? Did you see any bugs? So general insights on what happened and how did you find the testing. So um, what did you notice when doing the testing level that you performed in your group? So we can start also, I can just say, let's say with the component testing, and then we go to the integration and so on and so forth. So if anybody from that group wants to share, you can also write it in the live chat if that's better. So don't worry, there are no wrong answers. Again, this is just an exercise, so you can just type down, for example, we went through the drop downs, the checkboxes, everything was working as expected. We noticed, for example, that we can't do maybe the drag and drop scenario. We can write whatever you wish uh, that you discovered during the testing. So wonderful. I didn't go much into this. It's okay. I guess it was some my network problem because it arrived a bit late. So we see here from in the live chat, so unit testing, I can actually draw it here so we can all see it together. The checkbox working, the drop down, drag and drop working is attended, integration. We also did integration testing. That's very wonderful. I talked a bit with all of you. Login form authentication working as intended. So wonderful. So basically you went through all of them. You made sure that the components themselves and isolation worked. And you also did some integration testing, which I very much support. So good job for that. Some of the other teams want to share regarding the integration, system testing, acceptance testing. I see some of you are typing, so I'll give it a bit more time. All right, we see another information here. jQuery UI menu test provide the PDF as expected. Wonderful. Okay. I want to see, does anybody from the acceptance test team have any suggestions maybe also? That would be also a good insight. Surprisingly, the geolocation actually opened Google Maps and had a moderately accurate location for me. Okay, that's good to hear. All right. We see another one from the component, login page with different username and password. Oh, okay. System testing. File download worked as expected. Going back to the jQuery menu is not ideal since it does not redirect to the menu page. It's a very good, this is actually even a bit of acceptance testing here because you have added this sort of suggestion. So going, since it does not redirect to the menu page. So this is a very good insight, I would say, and it will be something that could be taken into consideration and should be in the final stages. We're tasked with going to the jQuery, click on enable download PDF. This worked as expected. Tried other file types such as Excel and CSV as well, and this was downloaded as intended. Wonderful. I love the detail in it, so very good for that. It's always welcome to have this detail. All right. I see other people are still typing, so I'll give a bit one more minute of time. So let's see. Integration testing, there we go. Basic authentication, working as intended with correct credentials. With wrong credentials, appropriate error message are not showing. All right, so we see that the error message is apparently missing. This is a very good catch. So in this scenario, we would probably need to have maybe some kind of error message. So that did not happen. So I will just now move the chat into my other window here and want to basically summarize everything. So we noticed that everyone that was in a different group had different assignments. We even see from what we shared in the chat. So people did different types of testing. We also got the acceptance testing now, disappearing elements, all pages not found except home, where it shows us the main page again, broken images, 2 images were broken. Wonderful. So we see that with the different types of tests, we covered different aspects of this single application. So we covered a lot more ground. We found where we have some specific issues, even scenarios where, for example, in the system testing was okay, in the integration there was not. So we see that we covered a lot more ground. We found things that would need to be modified. We added suggestions also from the acceptance testing perspective. So we see that having all of these into one kind of gives us a better perspective and a wider coverage and a better structure when working